Hey everyone, welcome back to the channel. In the last series I focused on deploying a React web app to the major cloud providers. In this series we'll be taking a look at how to develop and subsequently deploy a FastAPI application to the major cloud providers. As always, links to my GitHub can be found in the description. To develop our API application, we'll be using FastAPI. FastAPI is a modern, high-performance web framework for building APIs with Python. It offers a lot of great features which you can learn more about by visiting their documentation. The link's in the description. Let's get started with setting up the project. Open your terminal, navigate into a new directory, and create one for the project. I'll call this one FastAPI Demo. We'll create a requirements.txt file and we'll add the following packages: FastAPI, which is our API framework, struct_log, which provides structured logging for Python, and Uvicorn, which is an ASGI server. Now we can create our virtual environment and install the requirements that we just put into the text file. To develop the API, we can start simple with one file. Let's call it main.py. We need to import FastAPI as well as struct_log. We define both our app and our logger using these simple one-liners. Next, we'll define a route. This will be the route path denoted with a /. I'll add a logging statement as well, and we should be good to save and run it. Head back to the terminal and start the app using Uvicorn. You'll notice that main is directing Uvicorn to the main.py file, and app is the name of our instantiated FastAPI application. The app should be up and running on localhost port 8000. Notice that our logging statement is captured as well. Another great feature of FastAPI is the auto-documented routes that leverage the Swagger UI. We can check it out at localhost port 8000 /docs. Using FastAPI, we developed an API really quickly. Now we can turn our attention towards the architecture. When developing, I want my local environment to be as close to the environment I would run in production as possible. To apply this to our application, we need to do some cleanup and preparation using Docker. Back in VS Code, create a new folder for the project. I'll just call it project. Add a new requirements.txt file, and while we're at it, we should stop and clean up the virtual environment from earlier. For our requirements, we'll need Alembic, which is a database migration tool, AsyncPG, which is an asynchronous PostgreSQL driver, FastAPI, we used this earlier, struct_log, we also used this earlier, SQL model, which is a SQL interaction library for Python, and Uvicorn, which we used earlier. Be sure to remove the files that were created earlier. Create an app folder with an init file and a new main.py file. The init file in Python is used to make a directory a callable application. Instead of the route path, this time we'll create a health check route that can be used later in the cloud. To containerize the application, we'll need a couple of files. First, add a Docker file to the directory called project. The second file we'll need is a Docker Compose file. This can be added to the root directory. In it, we'll define a service called API to represent our FastAPI application. Let's build and run the containers. You'll need to install Docker Desktop if you haven't already. To bring down our application, we can use Ctrl-C to get back our terminal and Docker Compose down to stop the containers. With containerization out of the way, we can set up our local database using the same technologies. In production, we won't have a containerized database as it's not best practice, but locally, it provides simple interaction without having to install more tools and more dependencies. In addition to containerizing our database, we'll also add application code that allows our API to interact with the database instance. Back in VS Code, add a new service to the Docker Compose file called db. We'll also want to update the API environment variable to include the database URL. Add a db.py file to initialize the database engine and create a new session. Add a models.py file to define a movie model. Our definition will contain 3 different models: movie base, which is a data-only model; movie, which inherits movie base and adds an ID to represent a database table; and movie create, again another data-only pydantic model, this time used to create new movies. Back in main.py, add a startup event that will create the movies table on startup. We'll also want to add some routes for getting and posting a new movie. We're ready to test it out. Back in your terminal, make sure the containers and volumes have been stopped. Then you can build and run the containers. The last thing we need to do is add Alembic to properly handle database schema changes. It would also be nice to have a persistent volume in our local database container, so we don't have to recreate local test data. Remove the startup event from main.py, since we no longer want the tables created at startup. Add a volume to the Docker compose file, so that data we create persists when we start and stop the containers. Build and start your containers. Notice the use of -d. This denotes we want to run our containers in detached mode. Now we can initialize Alembic with the async template using the following command. Using the auto-generated code, import the SQL model library into the script.py file. This will ensure the library is included when new migration files are generated. Now update the auto-generated env.py file. We'll need to import the SQL model library and our movie model. Then set the target metadata to our model's metadata. Finally, visit the alembic.init file and update the database URL. Back in your terminal, generate the initial migration file. Then we'll check that it was properly generated before applying the migration. Let's test making a database schema change to simulate making a database migration. First, we'll update the movie base model by adding an optional description field. Next, we'll generate a new migration file and clean up any unwanted auto-generated code. Then we can apply the migration. Finally, update the route handlers and test it out. That wraps up this video on developing an API with FastAPI. Thanks for watching.